Hello and welcome to the Terran Space Academy, where we help prepare you for a bright future in the space industry. Today I want to review the science of atmospheric ion engines and introduce you to a great channel I found. This channel is called the Plasma Channel, and it's ran by this guy. This is Jay. Jay does some incredible things with plasma, including building this device. This is what I will call a staged acceleration atmospheric ion thruster. Let's review what atmospheric engines are, and then look at what he's done. Forgive the audio quality, please. I'm not in my sound chamber today, and I was a baby YouTuber back then with an inferior microphone. Understanding atmospheric ion propulsion. In most science fiction, we see the shuttlecraft or other ships lifting majestically off the surface of a planet and flying into space. Some use anti-gravity. We're nowhere near that yet, so we will leave that to the writers. Some of the ships obviously have engines, but we do not see huge flames or massive plumes of smoke. There may be a nice blue glow from the engine pods. Is this type of propulsion physically possible, and how could we achieve it? Electric aircraft will revolutionize air travel once power density reaches about 500 watts per kilogram. Lithium-ion is at about 300 now, with 700 possible. Supercapacitors could reach 15,000 watts per kilogram. Now, we are not talking about generating power here. That is particularly important to understand. We are talking about storing huge amounts of energy for use before recharging. We will look more at power generation in other videos. So now you have a ship with a supercapacitor. A capacitor stores electrical charge differently than a battery. A battery charges and discharges by moving electrons or ions through a chemical reaction. A capacitor stores electrical power by reversible absorption and desorption of ions at the interface between electrode materials and electrolytes. They are great for short-term energy needs. A battery has an electrochemical cell that charges slowly, but can power something for a long time. Think of a battery as undergoing a chemical change to store energy. This chemical change is technically an oxidation-reduction reaction, though we are sometimes talking about electrons only and not necessarily oxygen molecules. The anode or positive terminal oxidizes or takes away electrons, while the negative terminal or cathode reduces or adds electrons. A lot of electrical terminology is backward because the early scientists thought positive charges were moving through wires instead of negative. The electrons therefore ended up being called negative, and the empty space they occupied in an atom's orbital was called positive. They had a 50-50 chance to get it right, and they blew it. So batteries undergo a slower chemical change to store electrical energy, but can store a lot of it, while capacitors just pack electrons on a metal plate until it cannot hold any more. Capacitors are good for releasing enormous amounts of electrical power, but are rapidly depleted. Batteries take longer to charge and discharge, but can hold more overall electrical power. Let's assume that our ship will have a theoretical but possible hybrid system with 15,000 watts per kilogram of instantaneous power with the supercapacitors and 700 watts per kilogram of continuous power. Supercapacitors, by the way, are different from regular capacitors. They use electrostatic double-layer capacitance, or EDLC. There is also electrochemical pseudocapacitance technology. Supercapacitors have two electrodes, a membrane separator, and an electrolyte. When voltage is applied to the surface of the electrodes, they absorb ions. It holds these ions until discharged. The pseudocapacitors don't undergo chemical change either, but there is electron transfer at the surface between the electrolyte and the electrode. Supercapacitors can store 10 to 100 times more energy per unit volume than regular electrolytic capacitors. Your ship will draw on the capacitors for bursts of energy to supplement what the batteries cannot provide in time. Let's assume that we are using the carbon nanotube-based nano supercapacitors that are being developed now. These are already being used in the space industry and have been validated from minus 110 to plus 250 centigrade, and they can survive over 1 million charge cycles. Now that we have theoretically solved our power problems, let's look at the engines themselves. Electric motors, like the ones in the Tesla Model 3, are very efficient. 97% according to reports by Electric. Modern helicopters work great up to an altitude of about 7,500 meters or about 25,000 feet, where they lose the ability to power their jet turbines. Now, our ship doesn't use gas turbines, but we are still limited by the speed of sound. The tip of the blade cannot go supersonic or it will tear itself apart, and lift drops with decreasing air density. So let's go all-ion and see what we can do. The first flight of an all-ion aircraft was performed by the Massachusetts Institute of Technology in November 2018. The technology itself was discovered in the 1920s, when it was found that an ionic wind could be created when a current was passed between a thick electrode and a thin electrode. When enough voltage is applied between these, air molecules striking the thick electrode in front are ionized and then pulled through the electric field toward the thin one. You will see these on YouTube sometimes advertised as anti-gravity. Sadly, it is not. Put one in a vacuum chamber and it goes nowhere. The MIT scientists and engineers were able to get their small plane to fly. So let's assume we can use this technology to take off. What are the benefits over combustion engines? The amount of your ship that must be propellant is one thing. With a propellant ejection velocity of about 4,000 meters per second, that means our ship must be about 95% fuel and oxidizer to get a delta V of about 12 kilometers per second. A little safety margin. That does not leave much room for anything else on your ship if it is 95% fuel and oxidizer by mass. What if our propellant ejection velocity was an incredible 100,000 meters per second? Our ship would only need to be about 11% propellant by mass to get us into space. The other 89% of mass could be the ship, passengers, cargo, crew, and of course the batteries and capacitors. But we are not going to use our onboard propellant at first. We are going to use electric-powered turbines to pull air into the engine, ionize it, and throw it out the exhaust. We will need more power, but we can save our onboard propellant until we are above most of Earth's atmosphere. Then get our lateral velocity to the right speed to keep us in orbit. Is it possible to use ionized air efficiently in a thin atmosphere? Not only is it possible, it has been done. The European Space Agency has developed an air-breathing electric thruster to overcome drag and keep low-flying satellites in orbit. Their design was able to scoop up air molecules to use as propellant with air as thin as that at 200 kilometers altitude and traveling at a speed of 7.8 kilometers per second, according to the European Space Agency's Lewis Wolpott. This is called ram electric propulsion. An advanced air intake was invented to collect the air molecule by Quintascience out of Poland. The air is given an electric charge in this intake and then accelerated as you see in this design schematic. They also supplemented the propellant flow with xenon, going from all air to all xenon. The different colors tell you what gas is being ionized. Xenon is greenish blue while the air is pink. It is mainly nitrogen that is being ionized in the air, but this makes up 78% of Earth's atmosphere, so that works out fine. This is the technology of the future. If we took a large blended body aircraft, had electric thrusters augmented with hydrogen, used large cryogenic hydrogen tanks to power hydrogen fuel cells while in atmosphere, we would need some ram scoops on our ship, like a jet engine intake but bigger. Something like this would be nice. Switch to electric air thrusters only while at high altitudes and gaining lateral velocity. Using hydrogen or argon gas for propellant supplementation when the atmosphere is too thin as we climb into orbit and on into space. We could have a single stage to orbit craft with a propellant mass much less than that of any existing form of space transportation. Now once in orbit, we'll use solar to recharge our batteries and supercapacitors, then use our remaining propellant to go to the moon, land, unload our passengers and cargo, reload some propellant, recharge our batteries and capacitors, and fly from the moon back to the Earth, using the ion engines to slow down as much as possible before re-entering like the Virgin Galactic ships do to reduce atmospheric friction. Aerospace rescue and fighter craft of the future, using air-fed ion drives, will be able to climb rapidly from a runway, fly at very high altitudes while gaining lateral velocity, and switch over to internal propellant to accomplish their missions in space. Read up on this technology. It will change everything. There are links in the description. This course was provided by the Terran Space Academy. Just like a jet engine uses multiple blades to compress air, each blade being optimized for that point in the compression cycle, instead of just one big propeller, Jay is using multiple ion grids to accelerate the air. This way you don't have to have a huge electric gradient between any two grids. This is much more efficient. He's not the first to have this idea, but you have to admit he has built a beautiful device. Don't forget to subscribe to his channel and watch the full episode on building this awesome engine. We have a link in the description. Many of you have asked about extra courses that you could take to help you work through the basic and advanced concepts needed to understand space science. To that end, we have looked at several science education courses that are available online. We came across some excellent courses at Brilliant.org. We reached out to Brilliant and they allowed us premium access to review their courses. And they have agreed to sponsor this channel. We have selected a variety of basic science and advanced science courses that we will highlight. Let's start with a lesson from Brilliant focused on the interaction of matter and energy. This lesson will cover basic thermodynamic concepts that are absolutely necessary to understand rocket engines. It starts with the definition and an explanation of heat itself, and then teaches you the flow of heat energy. This is critical to understanding heat conduction in rocket engine components and during re-entry. Then it covers concepts like pressure, flow in pipes, and buoyancy. These lessons will help you understand propellant tanks, hot gas feed lines, downcomers, and manifolds. Then you are ready to go to the advanced science section and watch their lesson on rockets. A deep understanding of the basics is how we come to truly understand a complicated subject, like space science. To get started for free, visit brilliant.org/Terran Space Academy, or click on the link in the description. The first 200 of you will get 20% off Brilliant's annual premium subscription. And the Academy will receive some financial support from Brilliant, which we appreciate. Thank you, and stay safe. At Astra Pro Terra. And now let's thank our Patreons as we watch this formerly classified nuclear-armed, nuclear-powered lenticular re-entry vehicle, designed and perhaps even flown by the United States over half a century ago. And don't forget to thank Hayes Gray Art by going to his channel and subscribing also. He allows us to see what might have been. Thanks for listening and stay safe. At Astra Pro Terra.